Dynaplast is a precision injection molder of high-temperature engineered resins, primarily for the automotive market. And we also have a sister division here, H2O Paddles, which builds kayak paddles for whitewater and recreational markets.
Thermoplastic kayak paddles are made through the injection molding process. In the injection molding process, you inject molten plastic into a mold. It's allowed to solidify, and you take that part out and then start the next cycle. Now, one of the main contributors to cycle time is the cooling process. So if you can find a way to cool the part quicker, you can make parts faster. So we worked with Mohawk College to develop this insert that can cool that part quicker so that we can reduce cycle time and in turn make parts much faster.
So this is the Additive Manufacturing Resource Center, the AMRC as we call it. This is a center for research in different forms of additive manufacturing. We've seen people walk through the door ranging from biomedical implants and thumb prosthetics to people that want to redesign the internal combustion engine and everything in between. In our partnership with Dynaplast, we were using our additive metal manufacturing to create a tool for their injection molding process. In creating a conformal cooling die, such as the one that we made in this project, you begin by designing the part and designing the cooling channels of the die, and then using something called thermal modeling software to analyze how the temperature distribution of the part will change based on the new cooling channel design. In an iterative process, then you can work through if the cooling channels should be shaped differently or should be closer to the surface or further away from the surface of the part, etc. You can understand how best to model the design of the part. We worked very closely with Dynaplast's team, and we went back and forth with them on the design of the part to make sure that the end result gave us the results that we were all looking for.
What's most exciting about applied research is the way that we can get students really involved in an industry problem. Partnering with a company like Dynaplast gives all of us the opportunity to explore a new technology in a really innovative way. So for a company like Dynaplast, they had the opportunity to access our state-of-the-art additive manufacturing or 3D printing machines, going through trial and error, coming up with better ways of designing the part at a much lower cost than it would be if they were to purchase the machines. It's done at a much lower risk.
The partnership with Mohawk is critical because it takes us out of our comfort zone, but we really need to continue to explore new technologies and see what advantages that they can bring to Dynaplast. So this collaboration, this ability to expand our knowledge base and being able to produce a part with higher quality at a faster rate will make us more competitive, and that's really the bottom line, that we build a sustainable business here in Toronto.